relationship between two variables, okay, just like this here. I think I showed you this table, baseball attendance table, okay? And I took just two variables from baseball attendance table, okay? And temperature and attendance. So the question is there any correlation or relationship between the two variables? Does the temperature affect the number of people attend the baseball game? Okay. All right, so we just quickly constructed, you can do it, so easily, just highlight two columns and insert line chart with markers, something like that. Or, no, you select scattergram. There's a separate choice for scattergram, okay? All right, and this is what you're going to see, okay? The next chart is time series. Time series is pretty similar to scatter plot, as you see here. Time series also shows the relationship between two variables, okay? But here, the difference is one variable. Specifically, the variable on the horizontal axis is time. Yes, okay? It could be years like this, or it could be hours or minutes or whatever you like, right? So, on the horizontal axis, we put time here, okay? And then we try to see or find what happens to your variable of interest over time, okay? So you can imagine many, different examples here. Number of franchises, okay? For certain, it could be McDonald's or Kentucky Fried Chicken or 두 마리 chicken, something like that, right? So, over the years, what happened to number of franchises, okay? But, you can think about the stock prices, right? What happened to stock prices, Dow Jones Industrial Average, okay? That's one very good example of time series plot. Let's see, money. You usually see it on the front page of any financial paper, okay? If you look at right here, right? That's a 5-day time series on what happened to Dow Jones Industrial Average, okay? And these days, they have interactive charts, so you can change all those things. Instead of 5 days, you can see 6 months and whatever, how many years you like, okay? So going back to this time series, okay? What's the difference between time series and scatter plot, okay? Again, key difference is one variable, especially the one on the horizontal axis has to be time, okay? Another difference is, what do you see? Can you catch the difference between these two charts? Any idea? On scatter plots, you can have multiple points for one x value, right? On scatter plots, okay? But in time series, you're not going to see that. Oops. Because the way that we have the data, we have one specific number, one number for each time value, okay? So there is a one-to-one relationship, okay, in time series data, okay? So that's the only difference. And we can easily see the relationship between time and your variable, okay? Okay, here we go. We have the last topic, almost last topic of this chapter, which is pivot table, okay? Pivot table is a very useful Excel technique, Excel skill or Excel function, okay? to create contingency tables. Okay? What is a contingency table? Does anybody remember? Well, we started with a very simple, the simplest type of table or summary. Okay? So we had categories and frequency. Okay? So A, B, C, 10, 8, 16, something like that, right? That's the simplest type of frequency table, or you can say it's a summary table. But sometimes we want to have two-way classification. Okay? So you can have type A, B, C, maybe size, large, small. Okay? So we have this two-way classification. Okay? That's what we call contingency table. Okay? So pivot table is an Excel function using which we can easily create the contingency table and do many more adjustments or manipulations in contingency table. In addition to this two-way classification, we can even have multi-way classification. Okay? If you learn well, if you can do this, you will have definite advantage in finding a job. Okay? I'm telling you the real story. My second daughter went to business school, and she was looking for an internship. Maybe she was a senior in college. Okay? And a company called for a phone interview. Okay? And first thing they asked her was, "Can you do contingency table in Excel?" Okay? Or I mean the pivot table. Okay? And unfortunately, my daughter didn't have any idea what pivot table was about. Okay? So she didn't get that job. Okay? There are a few functions I can tell you. Pivot table, VLOOKUP. Has anybody used the VLOOKUP function? VLOOKUP, HLOOKUP. Okay? There's a vertical lookup, horizontal lookup. Okay? These are another useful skills that you can master. Okay? Especially when you're dealing with a lot of data. Okay? These are very convenient data manipulation tools. Okay? Okay, so, well, without further delay, let's say. Okay? So how do we do this? We have this data. Again, this data are from bond fund XLS. Okay? We have type of government, type of funds, type of bond funds. Okay? Asset size, fees, expense ratio, return in 2008, and so on. Okay? So suppose you want to create two-way classification. Okay? On the one side, let's say row-wise, we want to have type of the fund. Okay? And then on the column side, you want to have whether they charge fees or not. Okay? Well, let's go back to the data. Let's see, should be somewhere here. Yeah, let me just use this one. I don't have the original bond fund data there, looks like, so I'm going to use this. Okay. So how you do is go to the data. Okay. And first thing is select insert here. Okay, well, let me maximize it here. Insert. The first item here says pivot table. Okay, and if you do here the pull down menu, okay, says pivot table, use pivot table, okay? And then you are asked to select the range of the data, okay? Right now, it selected the entire data. That's fine, okay? So I'm just going to leave it, but if you want, you can narrow it down for your purpose, okay? And let's say new worksheet, all right? And then you see this pivot table tool, okay? So in order to have, what was it? We had type and feed, okay? So I would drag, you can check or just drag, it automatically inserted here, okay? Or you can just drag it, let's say, where's fees? To here, okay? So it quickly created two-way table, okay? And put the type on the row side, okay? Row label, okay? And fees on the column label, okay? But we don't have any number inside the actual cells, okay? Well, this space is for that, okay? And you can have many different choices. What do you like to know? What would you like to know about this number, okay? Would you like to know count, okay? How many bond funds have government fund, the corporate fund, okay? Or would you like to know how many of those funds out of total charge a fee or not? Okay, so you can do it many different way. Simplest way, let's say I'm going to drag fee to here, right? It says kasu, okay, meaning count. Okay, it just counted the number of funds and classified into this table. Okay, so you know how to understand this. So there are a total of 90 intermediate government fund and 90 short-term corporate fund. Okay, and out of those 90 intermediate government fund, 55 do not charge fees, but 35 of them charge fees. Okay, and so on. Okay, so it quickly. Well, what happened, I clicked outside the table, so this tool disappeared. If you click anywhere inside the table, it shows the tool again. Okay, okay, so it just quickly counted all those things, okay, and created this table, okay. That's the first table we have here, right? Well, the only difference is in this table, they put yes first and no later. If you want, you can do that. If you want, you can change the order, okay? How do you do that? Option. If you can catch that, let me know. Okay, there should be some kind of sorting function here. Okay, just like sorting in other cells. Okay. Okay. It should be somewhere here. I'll find out if there's. I know there is a way you can change the order of the categories, okay? But it will come later. You know, my computer and the textbook use the English version of Excel, okay? And when I have this Korean version of Excel, it's slightly confusing. Okay, all right. So instead of this actual count, what if you want to see percentages, okay? Proportion. of each cell. Okay, so you can go to here. Here's the drop-down menu. Click on it. Okay, and the bottom here it says field value setting or value field setting. Okay, click there. Right now, the count is highlighted. Okay, so if you want, you can say okay, show value as, where is the show value as? Percentage total, there should be. Okay. Here. Here. I think it is here. Yeah, so this means a percentage of total. Okay? Percentage of total. Let's see. Yeah, right there. Okay? So change all the actual counts into percentage of total. So this, about 30% of all the funds, okay, here the total is 100% here, okay, belong to intermediate government fund that do not charge fees, okay. About 19.5% of the funds are intermediate government funds that charge fees, okay. Okay, so that's how you convert it into percentages, okay. But I think a couple classes ago we talked about the row total and column total. Okay, so you can do those things if you instead of right now these numbers are percentage of the grand total here. Okay, but what if can you quickly convert this into the percentage of the row total? Okay, well you can calculate 30.56 by 50, right? But you don't have to do that, right? In case you want to do the row total or column total, you can simply go here again, value field setting, and show value as, okay, and here, row, I guess this is percentage of row, okay, no, this percentage of column, isn't it? Right, because we have the 100% on, yeah, that's right, Yeol means column, okay, hang means row, okay, in Korean, okay, okay, so that's a percentage of column, okay, column percentage, okay, or if you want, you can change it to row percentage. There we go. Right? So among all the intermediate government funds, 61% do not charge fee, but about 39% charge fees. Okay? Right? All right. So that's what the next slide was about. Changing percentages. Okay? All right. Here. We are adding another variable here. So instead of two-way analysis, now we are getting into three-way analysis. Okay? So we have fees, type, and risk. We're including another variable. Okay? How can you do that? I mean, if you want to do this by hand, it's going to take some time, right? You know, you have to draw all the boxes and calculate all these numbers, right? But using Excel, it is so easy. Okay? Go back to here, okay? And you can simply drag risk down here, right? Right there, okay? So Excel is using two variables on row-wise, okay? This is row variable, okay? And one variable on column, okay? So now we have, among the intermediate government funds, we categorize all the intermediate government funds based on 3 risk levels: above average, average risk, below average risk. Okay? And you can do that. Okay? And you get the idea now, right? How many variables can you use in this contingency table? Any idea? What's the maximum number of variables you can use in a contingency table? That's a trick question, right? What's the answer? There's no limit, right? As you can see here, let me show you. What if you want to use another variable here, column-wise, okay? Is there another? I think we used all the qualitative variable, okay? But, let's see. Suppose you want to bring in assets into here, right? So what's going to happen here is, because we just brought in the asset size, okay, without grouping, right? So it's listing all the asset size, 12, 14, 22.6, 23.5, and there will probably be about 180 columns, right? Right? For one category which charges fee here. If you go somewhere here, yeah, here, up to this. These are all different SSIs among those bonds that charged fees. Okay? Oh, no, didn't charge fees. So here's a summary for no. Okay? And then it's starting once again for all the fees. I mean, the bond funds that charge fees. Okay? All right. So there is no limit. I mean, if it's up to you. If you want to bring, 20 variables on the column side, 20 variables on the row side, you can do that. Okay? The thing is, your table is going to be quite complicated, right? As I told you last class, the whole idea of descriptive statistics, or presenting the data, is you have to make it make sense. Okay? The whole idea is conveying your information to your audience. Okay? So if the table gets too complicated, it's not going to be very effective. Right? Your audience will not catch anything, or will not be able to understand what's going on in your data. Okay? So you have to use your discretion. Okay? You have to use your sense. You have to be sensible. Okay? In how many variables you can put into a table. Okay? And obviously this is not going to work. Okay? Well, since we have this table open here, let me show you once. Grouping. So in case you bring in the quantitative variable, how do you group these variables into different levels or different size levels? Okay. So what you can do is here in these are asset sizes, right? Just right click on any cell here. Okay. You can right click on any number here of the asset size, and here group. Okay. And Excel automatically inserted 12 there, because apparently the smallest asset size was 12, maybe $12 million. Okay. And the largest asset size was, 14,724,000,000, or whatever, right? Okay. So, what are you going to do? Well, I would say the smallest number, since we have 12 to 14, almost 15,000, I would start from 0, okay, and include 15,000. And that will include all the asset sizes. Okay? And then if you do this, then you're dividing the range from 0 to 15,000 by 1,000. Okay? So you're going to get 15 columns. Okay? But in my opinion, that's too many, still too many, right? So I would say if you want to do 3 groupings, I guess I'm doing your homework here, right? So if you want to have 3 grouping, what should I put here? 5,000, right? All right. There we go, right? So now we have a table which is much more sensible. Okay? Why don't you review this and see if you can understand how to create the contingency table. Any question? How to use pivot table function to create contingency table? It's nice, isn't it? Okay. Obviously, it can be quite useful. Okay, so we did all those things, adding the variables, and can easily change the statistics displayed. Okay? So what this means is, so far, we dealt with the count. Okay? Here we had the type, risk, fees, and the count of either fee charging fund or intermediate government fund, and we separated them into 3-level risk categories. Okay? But here, you can use entirely different variable here, right? So question I'm asking here is this. Suppose you want to know average asset size of those funds that belong to this cell, right? In other words, this is the cell for intermediate government fund with above average risk that do not charge fees, okay? And instead of count, you want to know what is their average asset size, okay? And I don't know. So 9% of 180 is what? About 16, 17 funds, or maybe 16 funds, okay? So obviously about 16 funds belong to this category, this cell, right? But they will all have different asset size, okay? But if you want, you can find out average asset size of those 16 different funds, okay? How do you do that? Very easy, okay? So here, just okay, so we use, well, since we already had, let's click, if you click here, you get this tool. Let's go back to, let's see, field, remove the field, okay? And we have this simple table, all right? And what you need to do is remove fees here, and just bring assets down here, okay? And what we have here is a count, okay? As I said, there are about 17 funds, okay? 17 funds that belong to this category, okay? But suppose you want to know the asset size, average asset size of those 17 funds, right? How can you do that? Any idea? Anybody want to come here and try? You should have some idea by now. Yeah, go ahead. Come here and do it. Give me some time to blow my nose. What? You do it? Yeah, it's quite different looking from there and coming up here, right? Okay. He didn't mess up anything here. Yeah. Okay. So just click down here, value field setting, and instead of count, just select average. That's it, right? So we have average asset size of those funds that belong here, right? And if those too many, if you think you have too many digits below the decimal point, you can certainly change the, just go to right click, format, where's format? Okay, format. Come on, okay. Number, how about nice looking 2 digits? All right, there we go, right? So we have this average asset size, okay, of all those funds, okay? Can you think of anything else? Any other possible manipulation of this table? I think that's pretty much it. So you know how to add any variable, any number of variables, column-wise or row-wise, okay? And you can choose the information you see in these spaces, okay? You can do average, but sometimes you want to do total, okay? What if you want to find out the total asset value of all those funds, okay? Then you can simply go here, value field setting, 합계 or total, right? Or you can, if you want to see the maximum asset size in that category or minimum asset size in that category, obviously you can do that here, right? Maximum, minimum, whatever, right? Any idea? I mean, do you understand? Do you have any question? You can convert them into percentages here if you like, right? Relative. Here we go. Yeah. What was it? Right here. I couldn't find how to make it the other way. Yes first, no second, right? So it was right here. You just down here, pull down the menu, or I guess it's already there, right there, right? Now we have yes, no order, okay? Okay, good. One last slide about the contingency table is right here, drilling down. Another nice feature of contingency table or pivot table, okay, is once you present this file to someone, suppose you submit your file to your boss, okay, Excel, you created nice looking table like this, okay, and include it in your report and submit it in electronic form instead of hard copy on the paper. You submit it as a file, okay? Then what your boss can do is, okay, I see all this summary data, okay, but I want to look at the actual data, okay, original raw data, okay? Then you can, or he can, or she can double click there, any cell, right? And the person will see the original data, okay? It's called the drilling down, okay? So whatever question the reader has, in case they want to see the actual data, they can see actual raw data in addition to this, the summary table or pivot table, okay? Any question about pivot table? Okay, good. All right. This is a summary or concluding remarks of this chapter. Final advice about the presenting the data using graphs and charts. Okay? In constructing your presentation, whether it's a table or graphs or charts or whatever, right? You should keep these points in mind. Okay? First of all, the graph should not distort the data. And the graph should not contain unnecessary adornments. Okay? I think these two things happen together typically. If you look at all those newspaper or magazine, you see lots of charts and presentation, and they try to make them very visually pleasing and interesting. And that's one thing you should try. I mean, instead of just presenting a table, it can bore the reader, okay? And it's not very clear. So in order to make your point, many times they create nice-looking pictures, pictorial, okay? Visualization of the data, okay? Something like this. Okay? So the idea on this chart was showing the reader what happened to the minimum wage over the last 30 years, okay? Between 1960 and 1990. Okay? So if you present just the simple plain vanilla line chart, right, it would look like that, right? But I guess someone got an idea, to make it more interesting. Okay? They used the dollar bill, a picture of dollar bills, and showed it this way. Okay? What do you think? It says bad presentation, and this is good presentation. Why? Can you think of the reason why? Unnecessary adornment? Maybe, yeah. I guess these things are meaningless, right? It's just a unnecessary adornment, okay? But also there is one very big problem here, very important problem, okay? Is if you look at the number here, apparently it went from $1 to almost $4, okay? Almost 3.90 or something like that, okay? Right? Less than 4 times, okay? But if you look at the size of these bills, okay, it's almost like 10 times. This bill is more than 10 times the size of this bill in terms of the area, right? So maybe the idea that the person had this measurement, okay, this was 1 centimeter, okay? So he made it 3.9 centimeters here. But you know what happens if you do that, right? Because the area is what? The width times the height, okay? It will multiply, okay? So instead of 4 times, you made it 12 times larger, okay? That's what we call distortion, okay? You have distorted the data and conveying incorrect information to the reader, okay? Do you understand what I mean? Okay? So you have to keep that in mind. You have to try to present accurate information as much as possible. Okay? The scale on vertical axis should begin at 0. Do we have any example of like that? Here? Right here. Right? We have bad presentation on the left, good presentation on the right. Okay? The only difference here is it started from 36, okay? But this one shows 0. Okay? So why does it matter? Why is it necessary? Okay? The thing they would not recommend is, okay? Is obviously in the case of this graph, the numbers are scattered between 36 and 45 within 10 number range. Okay? So if you take this advice literally, right, you have to include all axis, the scale on the vertical axis should begin at 0. Okay? So if you put 0, 10, 20, 30, 40, 50, okay? And you created this graph of, where is it? Okay, so minimum of 36, maximum of 45, okay? So 36, 45, you graph like that. Is it a good presentation? Why not? Right. In other words, you have wasted all this space, right? And it is compressed, and it doesn't really show the changes clearly, okay? So what they recommend is this. Insert some wiggly curve here, and just tell the readers that they started from 0. There are numbers below 36. Okay? So that's what that advice is about. Okay? How about here? The same thing, right? Too much compression, right? It doesn't show real changes, clear differences between the four quarters. Okay? So this is a lot better than this. You're wasting all the space here, meaningless space. Okay? And what about this? Why is the first one bad and second one good? What's the difference between the two graphs? I think you have an idea, right? The first graph shows actual frequency. The second graph shows relative frequency, right? And within the context of this material, this data, right, the actual frequency may not be very meaningful, right? Because if you count the just total number of students receiving A from each class, okay? What if the sophomore class is the total number of sophomore students are much less than other classes? It could be true. It could happen, right? So the more meaningful number is percentage. What percentage of each class receive A? Okay? So apparently, if you look at this graph, sophomores are smarter than other classes in this school, whichever school it may be, right? But here it shows the opposite story. Okay? It tells the inaccurate information. Okay? All right, I think that's about it. Any question about the data presentation? Yeah, you can, Hans Rosling is a Swedish sociologist. He's not a statistician, okay? But you can find many interesting videos made by him, okay, on YouTube. And you can do, lots of things. These statistics can be interesting, I guess. Okay. Any question? Okay, I'll see you next week with chapter 3, right? Here we go.